We all have a story to tell. Let's tell yours. Welcome to the Intellectual People Podcast with your host, Jason. Come together and listen to journey stories and more from interesting people. Welcome your host, Jason.
Welcome to the Intellectual People Podcast. I often post on forums, and I'd like to personally thank those forum owners for allowing me to post on those forums. In no particular order, they are audiosciencereview.com, audiocircle.com, audioshark.org, audiofilestyle.com, AV Nirvana, which is also the home of Room EQ Wizard and AudioLens, DIYaudio.com, gears.com, and Parts Express Forum. Thank you so much and enjoy. Today on the Intellectual People Podcast, I have Jim from ZeroSurge.com. How are you doing today, Jim?
Hey, how are you? We're staying warm here in the frozen tundra of New Jersey.
All right, Jim. Tell me what ZeroSurge is.
We're a manufacturer of surge protection. What we do is we use a different kind of surge protection, but we're basically a manufacturer of surge protection. And that's pretty much the only thing we do.
Did you always dream of getting into surge protection?
Nope, not at all. I didn't even know I would get into this until 2013. So,
okay, let's go back into your earlier days and tell me how you got to where you're at now. So are you an electrical engineer?
No, I actually started out in chemistry.
Interesting.
But I've always been involved in electronics side of chemistry. So, you could be into biotech or pharmaceutical or, just generic organic chemistry like petroleum and those kind of things, plastics. I started out, my first chemistry job was doing ceramic processing, so high-tech ceramics for substrates for microchips. So we had a contract. It's kind of fun. We did it with Coors. So most people don't realize Coors is a very large ceramic company. They do a lot of electronic ceramics. And so we had a joint venture with them when I was working at W.R. Grace. And we would make these substrates out of aluminum nitride and put chips on them. And then the chips would go to the military. It was for, I think it was Hughes Aircraft at the time.
Do you know what they were using those chips for?
No,
Oh.
We never got that.
Okay.
I was too low on the totem pole for that one.
And then what was after that position?
So we after that, I moved to a company that did testing. It was a company called Trace Laboratories. So they test circuit boards and for the military and for commercial applications. And so I was more the chemist side of it. So I did the material testing for alloy composition of the copper on the traces. Look for contamination on circuit boards, used infrared analysis to look for contamination. We used electron microscopy, those kind of things, failure analysis. And I did that for a few years. And then my wife got a job in New Jersey. So we moved to New Jersey in 97. And then I worked for a solder plant, again, electronics, the material side, doing QC for them. And that was a brutal kind of job because it's, we had 15 solder pots maybe that were thousands of pounds of hot molten material. And, even in the wintertime, you were sweating, going into the plant because you had to wear all the protective gear too.
Right.
So you're wearing, the heavy duty clothing, the steel-toed shoes, all that stuff. And so after a couple of years of that, I just said, all right, that's enough of that. And worked for an adhesive company that was also into electronic adhesives. They actually made the die attach adhesive for chips. And they had a lot of contracts with like the big telecoms, Cisco's, those kind of companies. But they also had this little smart card line where they made smart cards. And these are the original like early RFID chips. So they were taking them from Texas Instruments and Siemens and some other companies. And they were using the 13.56, I think, megahertz chips, and they would make applications out of them. And I was just kind of on the periphery of that, helping them with some things. And the 2000 election happened. So the Bush-Gore election. And our boss said, hey, we can make a voting machine that's better than these things that are failing. So we ended up making a voting machine.
Hmm.
And because I was the only one in the office that, growing up near DC, I had more of a, I mean, I wasn't political, but I knew about the process. And so I ended up being the person that was the QC manager for this product, and ended up even testifying in Congress. I got to sit in front of one of those tables, and they asked me questions. You know, why is your voting machine different? And our thing was that we gave you a receipt that had a random number, because in voting, you're now not. It used to be, voting used to not be private. You literally used to go to the courthouse and said, "I vote for John." And then the newspapers would write it down and they tabulate it and say, okay, 15 people voted for John, 10 people voted for Jim. That's the way it used to be until the 1900s. And then it became private for some reason. So we had this little receipt, and it had a random number. So you could go back and check to see if the vote was counted and if it was counted correctly. And so that was our kind of our gimmick. And we also had some other things, and it was computerized. And so the blind people could vote independently. And we actually had like a screen reader that would read. It was actually, in fact, the first sale we did was to the American National Federation for the Blind. Bought our first machine and used it to demonstrate how the blind can vote independently.
That's wonderful.
So, so it was kind of an interesting, but it was, long hours, travel all around the country. You go to a lot of conferences. Election people like to party. They like to stay up to 4 a.m, because this is like their 1 week of the year. They get to go out and be away from the government and their bosses and stuff. And so, but I was going to all the different ones. So it was like, it was 1 week for them, but it was 1 week a month for me. So it was like crazy. And it was too much. And then once the Gulf War happened, it was once we went into Iraq, because we had gone into Afghanistan, right? So then Iraq happened, all the money dried up. So it was just kind of like, all right, I'm getting out of here. So my brother-in-law had a business that was selling model airplane, like the drones and helicopters and stuff. And this is all before most people knew about those quadcopters and things like that,
Sure.
because his father had been doing it for 30 years. So, and had a hobby store, and they put him online, and it went from like 1 order a day to 10 orders a day to, hey, we need help. So I helped him with the customer service and packing orders. And then we moved out of a house and into a warehouse, and actually had like 200 or 300 hobby stores that we sold to. And we were importing and getting stuff from everywhere and just selling it. And we had our own designs for things. And Dave went to China and sourced brushless motors there were actually little IBM computer CD-ROM motors, and we converted them into airplane motors with a little propeller shaft on them and everything. And it was an interesting thing. I mean, Dave's, to his credit, probably a lot of the reasons we have these low-cost flying things is because of what we started there. Because at the time, the brushless motors were almost $200, and you had to get them from like Czechoslovakia or something.
Does that business still exist? Does his business?
It's still, no, I think he shut it down because, yeah, he's a computer programmer by heart. So he kind of,
Okay.
we could kind of, what happened was the 2008 recession happened. We kind of shrunk, and then we were going pretty good for a while, for about 5 years. And then it just kind of ended its course.
Okay.
Because then everybody started bringing in all these other things. And then there's a few other offshore places that just tanked the market. They basically took a $40 motor and made it $10. And so there was no money to be made in the US for doing that.
Gotcha.
So it just kind of, on its own, we just kind of were a victim of our own success in some way.
Okay. And then what?
And then I was kind of in between doing some selling of electronic components, and then I ran into Zero Surge trying to sell them to Rudy, the founder. And he said he was retiring and going to sell the business. And I said, oh, really? How much? Just kind of like as a, conversational tool, and I wasn't really serious about it at first. And he told me a price, and I was like, huh, that's something that I said, well, I don't have the cash right away. And he said, well, I'll finance it. So I was like, oh, okay. So then we vetted each other out. He liked that, I had a patent for the voting machine stuff, and he's big in the patenting. He's probably has about 40, 50 patents to his name. He has an interesting history too. I don't know if he would ever go on a podcast, but he probably be a good storyteller because he worked for RCA. I mean, he basically helped invent color television. I mean, some of his early patents are in color television.
Mm.
And so, when RCA was the big TV company, and so he wanted somebody who was going to be local, somebody who was going to who had roots in the area in New Jersey. And, I'd been here 20 years at that point. We have kids and, in the schools and everything. And my wife is from New Jersey. So, I think that's what, we kind of synced up,
Yep.
and he also liked the way, my goals for the company, what I thought needed to be improved, being that he was older, he didn't know all the social media and stuff that you do nowadays. And, I wasn't going to I wasn't going to like move us into a new building we're in an old chicken coop. He built this business inside an old chicken coop. So,
Yep.
So there's no reason to leave if it's working,
Right. Sure.
And he had other buyers that had been like, okay, we're going to move out of this. And he's like, where are you going to get the money to do that kind of stuff? So,
Right.
what are you really planning on doing with the product? That's really the key.
Did you go in as a buyer first, or did you go in as a working for Rudy first?
No, I went in as a buyer.
You did.
Basically.
Okay.
Yes.
Let's go back and just quickly, if you don't mind, explain who Rudy is and what he means to Zero Surge from inception, if you would.
Okay, so again, Rudy is a electrical engineer, very smart, but he's also like a gentleman farmer kind of guy, right? He's very practical. He literally has he has a chicken coop on his own house, and he had apple trees, and he wasn't a big like dairy farmer or something like that, but he had some chickens, and so he had that sensibility, a very practical guy, not very flashy, wearing, just button down, flannel shirt kind of guy,
Yep.
And but very smart, very quiet. He's like a quiet genius. He's not a showman, like more like me, I guess. But he very so he started the company because he had finished working at RCA, and he was consulting, and one of his companies he consulted for, I think, was Samsung. And well, I know it was Samsung because we still have the plaque from them. They gave him a plaque for his work, but he was consulting in their their data centers. And back then, data centers were, this is in the late '80s, so it's just basically you had the big mainframes, but then you had a bunch of rooms with, 20 people with 20 computers doing, CAD drawings and stuff.
Right.
So they started having failures of their printers and network equipment, and they're like, why just them? Why not the computers? And they're like, we're using surge protection, but it's not working. And so he said, well, let's figure out what's going on. What is a surge? What are they trying to do with the surge? And what's the problem? So he deduced that the surges were getting diverted to the ground line, and the ground line in a building is for our safety. We're familiar with that third little tiny prong that is the ground pin, and
which is the round one, right, Jim?
Right, the round run, right, the little tiny one.
Yep.
And so he, realized that, the other devices that use the ground line are the network equipment, because they need ground as a reference point when their signal goes across. Because when you send a signal, it's in voltage, and voltage is a reference. It's related to something, like how high. If this is 5 volts and this is 4 volts, and this is 3 volts, it's relative to some base zero number.
Right.
And so you use the ground line as a reference. So if you change your ground line by putting surge damage on it, it can be above your signal or below it, or it could travel through that same line into the back of your printer, into the back of your network equipment. And that's what's burning out the equipment. So it's actually failing from the backside, not from the power side.
Interesting.
And so he, said, well, how do we solve that problem? And so he basically came up with the idea of using an inductor and a capacitive bank. And so what we're doing is he looked at surges as, AC power oscillates 60 times a second. It goes up to 170,000 or 170 volts, down to minus 170, and it oscillates. And so anything that's vibrating faster than 60 hertz is a surge by definition. So we don't care if the surge is have a lot of voltage or if it has a lot of current. If it's going really fast or if it's really going, really high. And so he said, well, how do you handle both at the same time? The traditional surge protectors wait for just the height. They're looking for something to happen at a certain peak, and then they act after that.
Okay.
So what we're doing is we're saying, all right, let's just filter everything that's spinning faster than 60 hertz. So what engineers call low pass filter. We let low frequency pass through and we filter everything above that. So use an inductor. It's a magnetic kind of coil, and then capacitors hold that energy, and then we send it back out to the power company. So instead of putting it on the ground line, we put it on that second line that comes, out of the wall. So the first line is the line that brings power from the power company and then goes back out through the neutral, which goes out to the power company.
Which, for people listening that don't know wiring, there's typically 3 wires, right? There's a green wire or bare copper wire, which is your ground. There's a white wire, which is your neutral. And then there's a black wire, which is your hot, correct?
Right.
Okay.
Or line. Sometimes they call it the line.
Line. Okay. And
so the line is the power coming from the power company, goes through your device, which is considered the load, and then it goes back out through the neutral, back out to the power company to complete the circuit. And so we're sending it back out to the power company, but at a very safe level, because we're just slowly bleeding it back out.
Is that what it is? It's just really slowly going back out?
Right, because the capacitors fill up to whatever level they fill up to. So, and they have a very small hole. So you think of it like a bucket of water. You'll hear me talk a lot about using water as an analogy. So it's like, the one really good analogy is like, power is like going through a hose, like water through a hose. And the car runs over the hose, you get a surge. Right. So that's basically like a big motor pulling power out in your house. It causes a surge. And then you're trying to water these really sensitive grass seeds with this hose. Well, if a surge happens, you knock over the grass seeds, you'll kill them. So the way you do it is you have the water go out of the hose into a bucket that has a hole at the bottom that's the right size of water letting it out. And so we don't care if there's a surge in the bucket because the bucket's big enough to handle the surge. And that's one way of looking at it.
I like that analogy. How many times a day are there surges, would you say, in the average home in the U.S.?
Well, the IEEE, which is the group that a bunch of electrical engineers, they did a study years ago, and there's about 1,000 surges a year that are the worst kind of surges, and then there's hundreds and hundreds during the day. Basically, anytime you turn on and off a light switch, you create a surge because you're interrupting that flow of water again. It's like somebody pinching the hose. So it could be hundreds of times in a building. In fact, 80% of surges come from inside your building, not from outside. So, your coffee pot, every time it cycles on and off, your heating, air conditioning, ceiling fans, hair dryers, laser printers, when they heat up, pretty much any device that sucks power is going to interrupt that flow of power.
Is it safe to say that surges, whether small or large, have an effect on electronic equipment?
Yes, because what they're doing is they're kind of shocking the components. So there's a rating for every component for how much shock it could take. So they do last, they'll survive the first few times, even on the small surges. But it's kind of like what another company calls it electric rust. So it's like an erosive effect. And so eventually, once it reaches a certain level, it just catastrophically fails.
How much will a zero surge unit protect in terms of, you're saying over voltage, right? If there's a surge and there's over voltage, is that saying that the capacitance of the zero surge unit is what is actually protecting so it doesn't go over a certain threshold of voltage?
Well, it's actually the inductor that's actually slowing down the speed of that surge because we don't care if it's in voltage or current. So if it's an inrush of current, which happens when you turn something on, just like you turn on a hose, you get that first burst of water coming out. It's the same thing. So we don't care where the surge, what component it is, as long as it's moving faster than it should, either in voltage or current.
What is the specification for over voltage? What will your unit basically cut it off at so X electrical device doesn't go above 100 and whatever the number is?
Okay, so there's two ways of looking at this. So we're rated for two ways. One is what's called the VPR, which is the voltage protection rating, and that's the minimum level of voltage that will let go to a device. Now, UL, the underwriters for safety, that's our organization that qualifies our product. That's the organization we make our product to their specifications. They will not list anything below 330 volts. So they say if it's 330 or lower, that's what it is, 330. So ours technically is lower than 330. It basically rides the wave. So we're actually following the peak of the wave. And so it depends on where you're measuring it, but at the peak, so it'd be like 180, 190 volts. It really doesn't allow that much through. But then there's also the other aspect on the other end of the high end. If a surge energy, we're rated for a maximum of 6,000 volts through, because that's the max definition of a surge. Once you get past 6,000 volts, then you get an arc. So then it starts breaking down the insulation of the wire. So at that point, you're starting to talk about lightning at that point.
Right. And at that point, there's really nothing that's going to save it, right?
No, lightning, there's nothing that prevents lightning from damaging things. Well, you can have some sacrificial things that'll try to divert lightning. I mean, that's what a lightning rod is. But it still eats up lightning rods if it actually touches it. So,
got it. Some people buy surge protectors that have different technology, correct?
Yes.
What is that technology exactly?
Generally, they're called shunt mode, which means they divert the surge. So they're most of them use a component called a metal oxide varistor. We call it MOV. I know we don't like to use acronyms for this stuff, but we're going to have to, or else I'll be saying metal oxide varistor 50,000 times. So if you hear MOV, that's what we're talking about, is basically anything that you'd buy at a store right now is basically uses an MOV. They all use the same technology. So what they're doing is they're waiting for the surge voltage to reach a certain level. And then at that point, they open up a gate to the ground line and then and so the energy will follow that low resistance to the ground line. And so it interrupts power for that brief amount of time. So if it's a 50 microsecond amount of time, which is 50 millionth of a second, it actually diverts the energy to the ground line, including all the good energy too, not just the surge. So it's actually interrupting power at that point, technically. Now most devices have capacitors that hold power for a long period of time, so you can handle a 50-second interruption, but they're counting on that actually, that it exists, or else they would have problems. And so that's how they work.
Are they bad?
Bad? That's a loaded word. So I would say they're not effective for what the problem is.
Why is that?
Because again, they're waiting for the surge to happen. So ours is acting as soon as we sense that it's vibrating faster than 60 hertz. So we get it before it ever peaks to a certain level. Because even at 400 volts, you're still going to start causing damage to your components.
Why are they so common if they're not necessarily ineffective, right? Because you're not saying they're ineffective. You're
Right.
more...
They're less effective.
They're less effective. but they're also only effective once or twice, correct?
Well, yeah, they're basically okay. So the history of that, you have to understand the history of it. So power supplies used to be what's called linear, and so they were voltage sensitive. So back then, back before the 80s, it made sense to use their kind of technology because you're using something that works on voltage to protect voltage sensitive equipment. Well, Apple is the first to really use switch mode power supplies for their full lineup, and so since then everything is switched to this switch mode power supply, and they're more energy efficient and some other advantages. And a switch mode power supply though is current sensitive. It's actually not voltage sensitive. Like your TV, you could plug it in and go bring it to the UK and run it on 240 volts. Whereas here it runs 120. So it's not that it's voltage sensitive, most devices anyway. That's why their effectiveness is less too, is because the problem has changed in the last 30 years and they didn't change with the problem.
Are people wasting money then on a $9 power strip?
A $9 power strip, probably not. And I'll tell you why. Because I understand, like, our product is in the $200 range, so that's, so for people know why you mentioned $9. Their technology is sacrificial. So they, like you mentioned before, one or two big surges will definitely knock out a power strip of any kind, any of the surge protectors. And so you want it to be your canary in the coal mine. So a $9 surge protector would be better than a $50 surge protector. So if you take a brand if you're looking at Home Depot and you're looking at the two sets of surge protectors and you have a $9 one and a $50 one, people think, I better buy the $50 one. It's better. They call it a higher joule rating. And I'm like, well, it's a sacrificial technology. So you want the canary in the coal mine. You want the canary to die, not the coal miner. So you don't want your equipment to have a higher joule rating or a lower joule rating than the equipment that the protection device. You want it the other way around.
Interesting.
Because if you don't do that, what their higher joule rating lets more energy through. The reason it can say it's a higher joule rating is they're set to even a higher voltage than a cheaper one. Cheaper ones are set really much at the bottom. Now, the caveat again with the cheaper ones is that they can't run continuously above 127 volts. So there's that caveat. There's a lot of, like, just in physics, there's always a balance, right? Of properties and stuff. So,
and it's important to say that you're saying that not so people do order a zero surge unit. It's that they might have a $9 power strip or even a $4 power strip. And basically within a year, is safe to say, it's already used up its life.
Right.
It might still work and someone might be able to get power from one of the 4 to 6 outlets, but it's not protecting anymore. Is that indeed true?
Right. That's probably true. In fact, when I came here, I got all my old surge protectors in my house and wanted to show them to Rudy and say, here, let's test them and see how bad they are. And he took one of them and he shook it. He goes, hear that? It sounded like sand inside there. And he said, that's the MOV. It broke apart. It's already dead.
And that it's also important to say, and I'm not just saying this for glory, is that it also becomes a safety factor. Right.
Yeah, because there's two modes of failure. Because it's a sandwich of material. And so it either gets hot and then it melts together and fuses and you get these hot spots. And that's when you can get a fire. Or it breaks apart, like the one that sounded like sand in my thing. So that's a good way for it to fail, is it breaks apart and nothing happens. You don't want it to fuse, and that can happen. A lot of them have tried to mitigate that by enclosing them in ceramics so they can handle the heat, which there's a Taiwanese company that makes that component. So there's that too. And the other thing I want to mention, because you mentioned like the $4 strip, the odds are a $4 strip isn't even a surge protector. So you can buy just a strip that's what's called a relocatable power tap. And the way you can tell if yours is a surge protector or just a power strip is look for the UL rating. So if it says UL 1449, then it's a surge protector. If it says UL 1363, then it's just a relocatable power tech. The power strips are just a power device. It's a power distribution unit. It's not a surge protector, and they probably won't fail because there's nothing in them other than a strip of material.
Got it. On the other side, there are things that are called whole house surge protectors, right?
Right. Mm-hmm.
Those operate on the same MOV
Mm-hmm.
topology.
Yes, they do. The difference is they use bigger ones so they can survive at the service entrance, I imagine, is the reason. But they also have a much higher voltage protection rating. So they start out at, I've seen them as low as 600 volts, 500 volts, all the way up to 1,000 volts, depending on what company you look at. We look at it this way: is 80% of surges originate from inside your building. So, if you put a guard on the outside of your bank vault and 8 out of the 10 burglars are inside, it's not going to help you.
Yep.
That's one way to look at it. So they also say, well, you need a layer of protection. So you need to have inside surge protection on a power strip and have us. And, if you feel comfortable, it's not going to hurt you because it probably won't do anything anyway. Because the inside one's going to do all the work anyway. Because as the voltage rises, it's like a tide rising. So as the voltage rises, the inside one acts first because it's a lower protection rating. Just that'd be true even for MOV strips, not just our technology.
Okay. Wouldn't a whole house surge protector protect appliances, ovens, microwaves, washers, dryers, anything that's electric, hot water heater?
Well, there's the things that protect big appliances is having voltage. We're finding out as I've been doing this and getting more, we don't necessarily deal with appliances, the big appliances, because they have a lot of power. The amount of energy in the max surge is only 90 joules of energy, which is the equivalent of 90 candles burning, because a joule is about one joule is about a candle burning, something like that. So it's not a lot of energy. It's just that it's happening very quickly. In an electric oven that has 40 amps going through it, that surge is actually nothing for that. It's really these sensitive low power, like computers, TVs now that are very low power. They have the really sensitive components in them. Even a refrigerator that has a computer built inside better have some isolation from that motor that's creating the surges to begin with. What happens in appliances is that if you have too many heavy appliances on the same side of your breaker panel, so in a house you have two sides of a breaker panel because you have two 120s that come into your house, and every house is the way they do it. And if you put all the heavy duty equipment on one side, then the power company can't support that voltage that's running your equipment. And so if they all happen to run at the same time, the refrigerator, the heater, the stove all happen to cycle at the same time, the voltage will drop. And for motors, that's bad because the current will rise to meet the power demand of the device. So a simple calculation would be if you have a 1,000-watt device and it's drawing, or say 1,200, the math is easier in my head, with 1,200-watt device. So you have a 1,200-watt device at 120 volts, that means you have 10 amps of current, right? So if the voltage drops to 100 volts, because just temporarily, then the current has to go up to 12 amps for that power to be met. Well, for most devices, the problem with motors specifically, the issue is the more current you put in the motor, the hotter the windings get in the motor. The hotter the windings, the more you degrade the varnish that protects the windings from arcing. And so again, you get kind of that similar catastrophic failure all of a sudden, and then the motor fries. And then the technician comes in and says, oh, it was surge damage. It's like, no, it wasn't surge damage, because a surge happens within one oscillation of power, 1/60th of a second. This is happening over several minutes probably, and maybe a few seconds after that. So it's happening in a 100 times longer time period, and that's really what the root cause for that stuff is.
The best way then is to load balance your panel, which is it safe to say that any licensed electrician would do that in the beginning?
Yeah, they should.
Way?
Yeah, the problem is when you do the renovation and the electrician gets a little sloppy and he's like, oh, I'll just put the new hot tub you just bought. Because that's what happened. That's what this all started, was a customer for one of our electrician customers, had this fancy home and they kept adding to it and adding to it. And then the other electrician was just throwing stuff wherever on the panel. And he started looking at the balance of it. He's like, I'm surprised you could even run the equipment.
Interesting. Okay. Let's assume that you have a properly loaded panel and it's balanced with power. Zero surge units are meant at what you call as a point of use unit, correct?
That's correct.
Which means that wherever you're using a device, it would plug into that unit, which then plugs into the wall.
Right.
Right?
Right.
Number one, tell us why that is advantageous. Number two, explain to me how your first example of a surge coming through the back end, if you will, through Ethernet is solved with a zero surge unit when your computer is only plugged into that unit and not Ethernet cable that goes through the zero surge unit.
Okay, so the first question, so plugging it in at the point of use, or like we also have hardwired versions. So if you have like a dedicated line, but basically you want to be there because again, the surges are originating from inside the building. So, for example, Wendy's is one of our bigger customers. They use us to protect their cash registers. So a cash register is actually like a very cheap computer. Generally, it's very cheap because it's a very price competitive industry. So they're always going to be using the cheapest device for the product. So very sensitive to any fluctuation. And then if you're in a restaurant, you have a lot of surges because you have the fryers, you have the bigger air conditioning, freezers, all that stuff. And it's in a small, compact building. So you have a lot of things. So it's like having a lot of hoses and a lot of cars riding over those hoses, right? Yep. And you only have this little tiny patch of grass seedling that you're maintaining. So, so if you don't protect it at that point of use, then you could be hit from all sides from other devices. And so, you want to be as close as you can to it. It also helps for electromagnetic interference too, because we filter. Part of the kind of an added benefit to our product is we filter out EMI noise too, so you don't get the radio noise that could mess up computer systems too. So again, that works better the closer you are to the device.
Okay.
And then the second part to your question, if you take the MOVs out of the equation, that automatically starts protecting your network because there are no surges on a data line. There's no energy on a ground line. So the only time you have energy on a ground line is if you have a fault, something broke, and it's there to protect humans from getting electrocuted, basically. So if you take MOVs out of the equation, you don't have that issue. In fact, a lot of MOV protections will sell you network protection that you plug into the network into their power strip. And I remember discussing that with Rudy, and he was explaining it to me. And I said, oh, so they're actually creating a product that protects you from themselves. And he goes, yeah, I never thought, but that's what they're doing. And that's the thing. So it's like if you take them out of the equation, you don't have that issue. And so, like the New Jersey Department of Environmental Protection, all their networks are protected by our product. And they've never had an issue since they started using. And that's, for years and years, probably decades at this point.
How long does a zero surge unit last?
We're not sure. Probably outlive both of us.
Really?
Yeah, there's nothing in the product that should degrade. So I guess practically, if you're constantly unplugging and replugging, I'm sure the receptacles, we use high quality receptacles. So I think they're rated for 10,000 insertions. So I mean, if you're doing that every single day, you know, eventually it's going to get loose, I would think, just from mechanical wear.
Sure.
But from the guts and how it works, like we have I always tell the story that so we can, because our product doesn't wear out, we can performance test it. So instead of just a QC check where you just make sure you got continuity and that it gives power, we actually run it through 13 different tests. And one of the tests is we surge, we hit it with surges, 6,000 volt surges.
Wow.
And we make sure that it lets through the right amount of energy and all that stuff. And so that's like taking a car out on the test track, run it for 1,000 miles, give it to you, and the car has no wear on it. The odometer still reads 0.
Right.
That's basically kind of how our product works. And so because we have this system run by a computer, it itself has a zero surge unit protecting the computer that's running the system, right? So it's being exposed to surges all day long. And when I came here, one of the first months, I said to somebody, one of the engineers said, how long this, I noticed, there was literally a dust ring around the box because nothing has moved in that area. And I said, I picked it up and I was like, oh, this was from 1996. So this is 2014. So, 18 years. And we did the calculation, kind of a rough estimate. And it's seen the equivalent of 186 years worth of surges.
Wow.
So if you go by the 1,000 worst case surges a year, it was around 186,000 surges that particular unit had seen.
Does anything light up on a zero surge unit if it does fail?
If it fails, the light would turn off.
Okay.
That's really what it would do. Because
so green light, and that green light would go off if it failed.
Right. Yeah, the green light's saying it's got power, basically. And if it has power, it's working.
That's it.
Yes. There's
no need for anybody that owns many of them to send them in to get tested every 5 years or 10 years.
No, we've had people who have some of the really old ones. We had one that was like 25 years old. And the guy was like, no, can you just test it anyway? He says, I'll pay for shipping. And okay. Put it on the tester, ran it through the same 14 tests. You could not tell between that and a brand new product.
Impressive. Very impressive. Okay.
That convinced me too that, when I'm telling these stories, I don't have to hem and haw about it. There's nothing to do. It's like the most boring product. If you will have dust rings around it.
Right. It just sits there, right? It's very
exactly
unexciting product.
Yeah.
It's
one of the other benefits too is it actually extends the life of your products. Like we still have a computer that runs DOS because it has not failed. And the system still works for what we're using it for. It's not connected to the internet. Who cares? It's doing its job, and it's the same monitor too.
And again, that is because the zero surge unit is not letting in the extreme voltage or amperage, correct?
Right.
So it's really keeping that DOS unit safe.
Right. We're just giving it good power, clean power.
Now, would you say that a zero surge unit is also what's known in the videophile and audiophile community as a power conditioner?
No, technically we're not a power conditioner because we don't change the power.
So
we don't change the good power. So that's always a caveat we have too, is like if you're experiencing voltage issues, we don't change it. We're not an AVR. We don't have a transformer that's gonna change the power and make it a certain way like a UPS would, or battery backup.
And why is that Zero Surge hasn't done that? Come out with a product that also changes the power in there's many different ways of doing so.
Right.
Why hasn't Zero Surge done a one box unit, if you will?
Partly because there really isn't a need for that. I mean, your equipment, like I said, I could run this laptop on 240 volts. So if the power is at 100, because Japan runs 100 volts, we run 120 and Europe runs 240. So most equipment is made by one company for the world. They just have different plugs. Right. So there really is no need to condition. If you have, all the things that our product prevents, you're good enough. There's no need, even in the audiophile guys, like you already have an amp that's doing that job for you. Most people don't realize a power amp is a conditioner. So you don't need another conditioner for your conditioner.
Right.
We're just protecting your amp from getting bad stuff, but you're conditioning the power because you're changing the AC to DC and then creating sound out of that.
Where does a dedicated unit, if somebody was to run a home run from their theater, say, back to their breaker panel, right? And they're going to run 10 gauge wire, say, because they have to have that dedicated 20 amp circuit.
Mm-hmm.
Where would one, and they don't want to use a point of use unit. They want that, right? They want a dedicated line to run from a zero surge unit. Does that unit mount in the garage?
You want it near the breaker panel because you need to be able to disconnect.
I'm sorry. Down here in Florida, the breaker panels are always in the garage, it seems.
In my house, it is in the garage too. But
okay.
But my parents' house, it's in their basement, actually.
Right. Yeah.
So.
Yeah, New Jersey is common with basements, where down here it's very uncommon. Or actually,
well, it would fill up with water, right?
Right.
If you did that.
Yeah. All right. So it would be a line from the breaker, say from the breaker to the zero surge unit, and then another line on the other end, right, going to the dedicated wire, correct?
Yep.
Or dedicated outlet, I'm sorry.
Correct.
And can you only run one dedicated line from that, or could you run a branch circuit so you can
run anything up to whatever the code would allow? I mean, as long as you're up to 20 amps. I mean, our dedicated product goes to 20 amps.
20 amps.
So,
okay.
So as long as you're doing something within code, that's fine with us. And as long as you don't put like a vacuum cleaner in the middle of it, make sure that those outlets are not being used for something that's going to create surges.
Right. And is that unit more expensive than a point of use unit?
Yes, because it has to come in a Huffman box, which has to have a UL rating. So it comes in a special UL box, and then it also can go to 20 amps. So it is a little bit more expensive, but not that much more.
Can you give me an example of what the cost is?
It'd be around $300.
Oh, okay. All right. So not awful. Definitely not awful. And really great for someone that has a dedicated line in a audio room or a video theater or something like that, right?
Right.
Okay. Do you sell those for what's the main purpose that you guys build those for?
I would say commercial applications. Like we have Wendy's was probably one of the first applications of that, but we also have digital sign companies use them. Alarm systems tend to not be plug-in, so we do like one of our big customers is actually the military use them in Korea for their fire alarms, for their hospitals and medical buildings. Some other hospitals use them. But yeah, I would say mostly it's commercial. Where it's some system like an alarm system, a access control system that's not just plugged in, and they don't want it ever to walk. So they don't want somebody to unplug it. And like with Wendy's, they started out with plug-in as they were doing the proof of concept, and then realized that those things can walk. So they have 5 branch circuits. So they have the point of sale, they have the menu boards that are now TVs behind them. They have the outside menu board for the drive-through.
Okay.
They have the office, and then they have another TV in the lounge. And so those 5 circuits, we created a bigger Hoffman box that has all 5 circuits in there. So they could just put one box in and then wire everything. They actually wire it above the office.
So is that unit available for residential use? If somebody had 5 circuits in a theater and they wanted that, is that something?
Yeah, they could.
Accessible?
Yeah, but they have to have an electrician install it. I mean, that's the code, because it is hardwired.
Sure, absolutely.
Or it has to be installed to code, put it that way.
Yes, correct.
Depending on where you are.
But they can still buy it, is my point, right?
Right. We do sell it, sure.
Yep. Okay, great.
And then one other thing that you didn't mention, but just so I could throw it out there, is that the actual guts itself we sell as an OEM module. So for people who are designing larger pieces of equipment, we actually sell that as well. There's companies that do like these big sorting machines for like the Amazon warehouse. They're down in South Jersey. Those guys use our OEM module. And so they actually attach it to their system so they don't have to worry about they don't need the Hoffman box because they already have their own box that they're putting it in.
Right. So a company can take that OEM or that OE unit, which is a zero surge unit, which is basically a naked unit, right? It's the guts, and then put it inside whatever device they have designed and manufactured, as long as it meets code, of course. And then they have that surge unit built in, correct?
Right. And see, our OEM module is UL recognized as a component. So the advantage of there is that they can take it, put it in, if they're a panel shop, is what they're called. They can use their UL certification to say, okay, we're doing this the right way. So they don't have to get it inspected every single time. They probably just have to get qualified for the original design. And then when they keep making product, they just use, the fact that our label's on there too. So
this is going to sound like a really crazy thought. Are consumers allowed to buy those OEM modules for their do-it-yourself projects, such as the audio guys? There's a huge community of do-it-yourself audio guys on DIYaudio.com, for instance. Are those people allowed to buy those OEM units for their equipment builds so they can put that inside?
We don't do that. We don't sell to, we vet people. There's minimums too. So yeah, because we can't qualify you to say that you're installing it. Whereas, I know OPEX is a company that's they have insurance, basically is what it comes down to. But, whether people have bought the plugin and pulled the guts out and played with it, I don't know.
And you can't control that, obviously.
Right. Well, I know people ask us a lot about battery backups because they kind of go hand in hand.
Okay.
As far as why do you offer battery backups? Why don't you? All that stuff. It's something we would love to be able to do, but there's some caveats and some complications because our product, you have to look at the logistically what it is. It's kind of like the equivalent of, okay, you have the audio files, right? They buy an amp, they buy a preamp, they buy a CD player, they buy a phonograph, they don't buy an all-in-one unit.
Right.
Because they justify the purchase because it's like, I need this amp because it has this quality, and I buy this CD player because it's got 5 CDs instead of 1, or I want this laser disc player because it can do European laser discs for my special collection, or whatever, right? And so there's a little bit of that concept that, okay, since one zero surge unit can protect any UPS, why would you put the two together? Because the UPS, first of all, doesn't last forever. So now you have to have battery compartments pull in and out, right?
Right.
And then now you're changing your whole philosophy that we sell something that never needs to be, replaced. But even if you get around that, because obviously, people understand batteries don't last forever. There's a little thing called entropy, that gets in the way. That, okay, well, what size battery do you make it?
Right.
So I have this relatively expensive component, the zero surge unit. Now I got to stock a 600 volt amp, 1000 volt amp, 2000 volt amp. Okay, well, now there's lithium batteries. So now do you want to use lithium? Do you want to use lead? Do you want to use nickel? I mean, whatever. There's some new thing that comes around that's going to change the battery world tomorrow. Who knows? Right. So it's like, okay, now you got to stock all those different sizes. So I don't, it doesn't make sense for us. The battery backup people use the metal oxide varistor. I mean, because it's a 5-cent part. So that's easy to do. You can stock all the different battery sizes when the thing you're attaching it to is only worth 5 cents. But when you're attaching it to something that, retails at $200, it's a lot different problem to have.
Right.
And so since we do work together and you can buy the 2-outlet one and plug the UPS into us, it's not daisy chaining because if it has less than 3 receptacles, it's not considered a relocatable power tap. So our 2-outlet model, gets plugged into the wall, and then you plug the UPS into us, and then the UPS has the 8 outlets on the back of it. And so you get the power through that, but we protect the UPS. We don't give it false trips because we're not making surges interrupt power. And so we make the battery last a little bit longer too.
Would you say that having a UPS plugged into a zero surge unit, that the MOV will never fail?
Probably will never get activated, right? So it'll just be inert.
Right. So it's certainly a safe unit to use then, and you don't have that concern going if it was just plugged directly into the wall.
Right, because it'll never get the voltage will never get high enough for it. Because in a UPS, they're actually set to usually 400 volts. Because you don't want the false trips all the time. You don't want these low level surges always interrupting power, and then the battery has to kick in, and then it keeps thinking there's power. I believe that's the reason, because there's no other reason to not do that other than maybe you want it to last longer.
Okay, that's a really good point then, and that's how I use them as well, for sure. Just for full disclosure, I have 10 zero surge units. I think I'm up to now. It just never seems to end. There's always another reason to get one. However, I've never had a failure, and many people around me in Florida have had a lot of failures. So I want to say it's the zero surge unit, but I'm not willing to take the risk and not have them at this point.
Yeah.
So full disclosure.
I appreciate that.
Yeah.
Well, I'll tell you one story too. We have a piece of equipment by a company called Dranich that makes monitoring equipment for power. It's very high end equipment. It's like Fluke is another brand, but we chose Dranich because it's a New Jersey company. So we, represent our fellow New Jersey manufacturer. And what's nice about it's like the size of a iPad, like a thick iPad. And so you can plug it in and it just monitors power. It actually is monitoring it. We have a special probe that does 1 megahertz sampling. So it's sampling 1 million times a second for power issues, because that's what you have to look for surges.
How expensive is this unit?
It's about $15,000.
Okay.
So we, I had it on for months at a time, just trying to capture things. And one cool thing we found is we're right near a solar farm. And it seems like literally at 3:45 every day we'd get a little ring wave come through. And I'm pretty sure it's that solar farm turning off, because they got to sync to the grid, and then they got to desync from the grid when they turn off. And it just seems like it was exactly like at 3:49 and 30 seconds almost every day. We noticed that for a while, and that's so we're pretty sure that's what that is, because there's no other thing that could explain that. Even the power, I've talked to the First Energy, the company that provides our power. Nobody could. They said it's not our switching activity, because they wouldn't do it at the same exact time every day.
Got it.
So there's that. But then last year, was it last 2 years ago? No, it was 2 springs ago. We would have, instead of the snow that we're having this year, we used to have these crazy windstorms where it was just 60-mile-an-hour winds. And then it was like every other week we'd have this crazy windstorm. Well, one time the wind must have knocked power out to us. And the way it knocked it out was a tree fell on a line, was bouncing on the line until it finally just broke, or the line, the transformer fried or whatever happened. So excitedly we go to look at the Dranich to see, okay, what happened? So the power went out right almost exactly at 1:00 in the morning. So from about 12 to 1. So knowing that we see maybe 3-4 events a day at most, in an exciting day, we see 4 events. How many events do you think we saw between 12 o'clock and 1:00? 14,000 events.
Wow.
So there was 14,000. It took about 10 minutes just to download the data, because it was so much data. Because it saves it when it triggers that there's an event, it takes the time before and after.
Sure.
So it was like half a gigabyte of data that was being downloaded out of this little tiny, it's a cheaper computer, so it took a little while through a USB thing. And when I saw that number, I was like, wait, is that right? And then I looked, and it's like, you see it just like event. And, some of the events were surges, some of it was voltage dropping, all these kind of things. Well, this was hitting everything in this building.
Hmm.
And it hit me like the next day, every single unit here is working fine.
Right.
Every computer is working, everything. There was one thing that failed. It was the LED light that's on the door because it doesn't have a zero surge unit on it. It was our canary.
Hmm.
And so I noticed because I usually the one that locks up at night, and I flipped the switch for that outside light, and I noticed the light didn't come on. I was like, oh yeah, we had that storm a couple days ago. I never noticed that it wasn't coming on. That's what failed.
Interesting. It begs the question of why not have, and I understand the expense with getting it approved and all, but a electric panel that has the zero surge built in for the entire panel, right?
Well, you could, but then you're assuming they're not going to use a vacuum cleaner on that circuit. That's one thing.
Will a vacuum cleaner really destroy?
Well, it creates surges. So if you have like a Dyson, because they have a 2-stage motor and they go between the 2 stages, and it's on the same receptacle, the same branch circuit as your TV, you'll definitely destroy the TV.
Got it.
So that's one thing we can't control that. Because again, you don't need it for everything. I mean, you have 10, right? You have more than 10 breakers.
Yep.
Right. So,
right.
It's a balance. And then, like you said, the cost of that.
Sure.
And then you have to have the arc fault now and the ground fault. And, at that point, you're talking about a panel that's probably like, weighs 1,000 pounds, and it's, you need its own wall, load bearing wall to attach it to.
Where does zero surge go from here? What is are there any plans for new products? Are there any plans for something different? Tell us something exciting.
Well, we just had, from the business side of it. So we're a small manufacturer. Yep. I mean, and, being that we're a small manufacturer, we get some help with local organizations. Every state has what's called the MEP, the Manufacturing Extension Program. It's run out of the Commerce Department, and each state has their own version of it. So our NJ MEP has helped us with different things over the years, as I've taken advantage of their help, because we get it at a lower cost. And they did they found the company that did our videos. They're helping us right now with our website where we do just updating it. But they also helped us with marketing stuff. So they helped us with getting a company that helps us with the social media posts and doing that kind of stuff. And so that's really helped our retail side of the business. We also added Amazon last year. So you can buy it from Amazon, not just from our website, which I was surprised how many people do. They could do both. They still buy from Amazon. So Amazon is another kind of new thing that we've been doing. And again, I'm surprised how well it's been working. It's actually almost like 8% of our sales now come out of Amazon, which is crazy. With no advertising, just threw it up there. And we only have 3 products that we're selling there. We did it as a test. They kept calling me and saying, hey, can we put your product on our website? I'm like, yeah, but you cost too much. And they're like, no, we don't. And we're like, yes, you do. And then finally, we kind of looked at the numbers closely and realized, oh, I guess it's like the equivalent of having a sales rep. If you take all the percentages down, it really is like 8% is what they charge you, because of the price and because of other factors. And they do the credit card and returns and stuff like that. So that works out. So that's one thing. So my point of mentioning all that is that we kind of have our retail side. We're on a good trajectory there. So then we had to look at, this year we're looking at our resellers. So we have a bunch of resellers that basically are installers or IT managers, those kind of thing. And so we've been, one thing we did just recently in the last 2 weeks was have webinars with them and find out what they want us to make, or, what their problems are, or how they help them, sell better. And so a couple of things we came out of the discussion, there may be something we had started, actually it's sitting right here. It's something like we're having something recessed.
Nice.
For people who want to do like AV installations.
Right.
We had tried making that in the past, there's still some technical hurdles and some mechanical things you have to get through, and then look at the pricing at that point and come up with a better design. Um,
And would that basically have an OEM module on the backside then? Is that the idea?
it's basically like another plug-in model. So yeah, it would have the chassis of the OEM module would be in there.
Right.
So it's kind of like combining our dedicated line ones with a plug-in, because
Yep.
you'd have to put it in a Huffman box so it could go in the wall. Yeah, I don't think our current metal would probably be rated for that, for being able to put inside a wall. So we probably have to put a Huffman box.
Got it.
That's a lot of that is now, what are the rules? How much, what size can you do? All these kind of things. So, how deep they'd want it, how many receptacles, 2, 4,
Right.
those kind of things. As far as other new kind of things, I mean, there's things that we can do within the scope of what our current certification are, as far as length of cords, maybe bigger, maybe 12 outlets. I don't know. I mean, we really has to be. I think the interesting problem about our product is that power hasn't changed, and basically the needs really haven't changed that much. So, the one thing I know people want too that we'd have to really go outside of our current expertise to do would be remote management of the power, because the IT guys like that, so they can turn on and off things
Right.
remotely. But then you got to deal with all the security and the IP, and because we had one here made by another company that we had used with our server, and in what 8 years I've been here now, only came in once where it even was remotely needed.
Right.
And then the problem was after 3 years, when PCI compliance started happening for credit card transactions, one of the things they do is they make you check out your network. Well, we failed. And I was like, why do we fail? We don't have anything fancy. We don't do anything bad. We have firewalls and all that stuff. It was because of that switch. I turned the switch off. We passed.
Interesting.
So then I looked into it and I found out it was never updated. So it's like, little things like that you have to be on top of, and it's, that would be, it'd be nice, and I'm sure people think they need it. I think most computers nowadays turn on automatically. They reboot when the power goes out, even in a long power outage. Modems pretty much restart themselves. So, how much of a need there is, I don't know.
Jim, do other companies license the Zero Surge technology?
We do private label for one company, and then there's another company that we originally made for them. Then they licensed it, and they kind of split away from us at some point, because then they got bought and sold by 3 other companies at this point.
So Brickwall and Surgex licensed your technology, Rudy's technology, which
Mhm.
I would imagine you still own, you now own, right?
Well, some of the patents have worn out at this point, so
I
they're
see.
not the secret sauce.
Okay.
So,
So
yeah.
Surgex, how does Surgex get around then making their own unit using the Zero Surge technology now?
They have patent. They have one of the patents.
They have one of the patents.
Yeah.
I see.
Yeah, Rudy gave them one. They have a different. It's a subtly different technology, but practically it's the same.
It's like
So
adding pepperoni to a plain cheese pizza.
it's like no, it's like having pepperoni pizza and then also adding a little capicola in there.
Okay.
Or salami.
Okay.
So it's basically the same. We're up to 2,000 volts, they're identical. After 2,000 volts, there's like a 4% difference. So it really their market though is more the pro audio. They did the Yankee Stadium sound system.
Got it.
They do casinos. So there's enough of a pie. I mean, me personally, I like that there are other companies selling it, because then we're not the crazy
Right.
company that only is doing it this way.
Right.
So I think a little bit of competition is great, because it shows that we're legitimate. They tell the story just as well. They they do a lot more road shows than we do because they're now part of a $1 billion company. So they're owned by AMETEK. So they get, all sorts of marketing support that spreads that word out too. So that's fine with me.
And their cost is higher. That's the other thing that should be mentioned, right? That their units.
Well, yeah, they do more too. I mean, they do have that remote capability on some of their units.
Right.
Some of their units have other bells and whistles on them too. So
fair enough. How many employees make up Zero Surge?
7 right now.
So it's you, Donna, I believe is her name, who if anybody calls, they always get Donna, it seems, and email.
Yeah, Donna and I pretty much answer the phones. She's been working home during the COVID. So that she's the only one that's been working home because everybody else touches the product.
And then it's manufacturing, and are there engineers involved as well?
Yeah, we have one engineer right now. We had 2, and then he went back to college to finish his degree. So he helped develop the unit we have that has USB.
Okay.
The 6R, if you're familiar with that one.
I am.
It has a 4-port USB. He actually helped develop that one.
Very cool. So small business, but obviously manufacturing a lot of product, right?
Yeah, I mean, we have about 60 different models all told, and then, but it's very easy to assemble, so we don't need a ton of people to do it, and we're not dealing with like surface mount chips and things like that. So it's all if anybody knows electronics, it's through-hole technology. It's all through-hole.
And you do all of the board assembly is done in-house?
Some of it is done outside.
Okay.
So we do some of the board stuff outside.
Okay.
But everything else is done inside. Some of it depends. Some of it, I guess, half of it, say.
Okay. Is there anything that I haven't asked you that you would like to share with us?
Donna will be remiss if I don't mention we do have military discount that we do. If you have proof of your military service, send it in to us, and we'll give you a special coupon code. And we expanded the program to where you can use it once a year. So we made it because somebody came back the next year, like, can I get another coupon code? So we're like, all right, we'll do it once a year. And the other thing is we don't have a lot of sales. We don't do a lot of gimmicks with that. So if you don't have to worry about looking for the sale, waiting to buy it. I always hated that myself as a consumer. We'll do the the Cyber Monday kind of thing. We've done different things every year. So if you really want to wait that long, you can, that's the best time to get the best price. But because we don't want to compete against our resellers. So that's the other reason we let them deal with that kind of stuff.
Jim, thank you so much. It's been a pleasure. I certainly have learned a lot, and hopefully everybody has as well. I will put some links below for some of the information that Jim has talked about. Please be sure to subscribe and smash that like button. Jim, thank you again.
Thank you very much.
Appreciate it.
Thanks for listening. Find us on YouTube and Facebook at The Intellectual People Podcast and online at theintellectualpeoplepodcast.com. Check back for exciting new episodes.